Handling radioactive materials is always dangerous. Even more so when doing it quickly is part of the equation. Radioactive pharmaceuticals have become important tools in modern medicine. After being injected into the body, they allow physicians to observe the cells at work. They are especially useful as an advanced form of cancer detection. However, there is a catch to their effectiveness. Some of the drugs have a potency lifespan measured only in hours.
One of the very short-lived radioactive pharmaceuticals is fluorodeoxyglucose. This material has a half-life of 110 minutes, which means approximately every 2 hours, 50% of the material decays by normal processes.
In order to rush the drug to hospitals and pharmacies in distant cities, drug manufacturers like Cardinal Health have turned to air carriers to transport them at high speeds. The success of the air carrier in delivering this radioactive material on time can literally be a matter of life and death to a patient waiting in some faraway city. Yet their transport must always be done with extreme caution. Here, Cardinal Health is creating a new shipment of the short-lived fluorodeoxyglucose, which is also known as FDG. A crucial moment in the process is when the drug is bombarded with radioactive protons in the lab's cyclotron.
During the bombardment process, a significant amount of radiation is generated by the proton bombardment. Therefore, we make sure that the vault is sealed and personnel entry is forbidden. All of our workers wear radiation monitoring devices to ensure that we monitor at all times exposures and exposure histories.
From this moment on, the drug is synthesized into a hazardous material, or hazmat, and is treated accordingly.
Following the synthesis of FDG, it's delivered directly into a lead-lined cabinet, which is called a hot cell. The walls of the lead cabinet are approximately 3 inches thick, as necessary to safely shield personnel during the handling of this material. We use remote manipulators, devices that allow the handling of the product from outside the hot cell.
Cardinal Health depends on techniques developed over the last half-century by the radiopharmaceutical industry. This industry is a direct byproduct of America's experiments with nuclear energy during World War II.
Radioactive materials in medicine, for all practical purposes, began in 1946 as an outshoot of the